So now we get to talk about our vertical stretches and vertical compressions. We've been talking about a function of the form f of x equals b to the x, where the number in front was just a 1. Well, now we're going to talk about if there is some other number there other than 1. Okay, so this is going to be the form that we're talking about now. We're going to use the letter a to represent that number. The function is going to be stretched vertically if a is greater than 1. Now, whenever we're talking about this, I'm not going to use this notation, okay? I'm going to be talking about a as just the number. If there's a negative in front of it, just ignore that. We're going to talk about the negative on the next page. So just look at the number. That's what the absolute value means. So if this number is greater than 1, it will be stretched vertically. Okay? It will be compressed vertically if this number is less than 1. Now remember, we're talking about it as a positive number. A sign will do something else altogether different. So if this number is less than 1, meaning if it's a fraction, then you're going to compress it vertically. This function has a y-intercept at 0a. This is something new, and it's a quick way to get your y-intercept. Let's talk about that for a second. To find a y-intercept, don't you let x equal 0? So look at our function. F of x is equal to a b to the x. Well, f of x is our y. So we have y is equal to a times b to the 0. But what is anything to the 0 power? It's just 1. So y is equal to a. So you can see now why our y-intercept is the point 0a. So now you have the explanation why we can just say that a is going to be your y-intercept. This next line is the same as all the previous pages. The horizontal asymptote is still y equals 0. If you just stretch it or compress it, it doesn't change where it falls on the grid. It just makes it taller or shorter. It still has a range of 0 to infinity, and it still has a domain of everything. Okay, so let's look at an example. We want to sketch the graph of f of x, state the domain, range, and asymptote. Well, what are all of these little things doing? Let's list our transformations. This is your b. What happens when b is between 0 and 1? Do you remember? F of x is equal to 4. 1/2 is the same thing as 2. Oh, to the negative x. Oh my goodness, I should not have thrown that at you yet. We're going to be talking about this on the next page, but this is a good thing to leave here because you'll see how it all fits together. Alright, so we look at this number. What's happening with that one? That is where your a is greater than 1, right? If a is greater than 1, it is going to be stretched vertically. So this graph should get taller and kind of skinnier. Alright, so let's just make a table so you can see what's going on. Let's pick these values again. We're going to plug them into our calculator just to save time. So we have -3, we're going to store that, and we're going to type in 4 times 1/2 to the, ooh, I did something wrong there. 4 times 1/2 to the x power. We get a whopping 32. (16) 8. We should know this one. Alright, so we can't really graph -3, 32, nor -2, 16. We might be able to do -1, 8 though. There we go. And then 0, 4. Do you remember we said that that's going to become the y-intercept? This number here is your y-intercept. Okay, so we can see that happening right there. 1, 2, 2, 1, 3.5, and this is going to get closer and closer to the x-axis there. Oops. I'm sure by now you're used to me drawing ugly looking graphs. Alright, so what is the domain of this function? It's going forever left, forever right. So the domain is everything. What is the range? Well, the range hasn't moved. It's starting at 0 and going up. Don't include the 0 though. And then the asymptote is still the x-axis. So the asymptote is still y equals 0. So we have our graph and all the little bits and pieces. What I want you to notice is that b was 1/2. So it's between 0 and 1. Which means we have a negative exponent. Remember, if you flip this over, you make the exponent negative. Look what happened to the graph because of that. So if we have a negative in front of the variable inside the exponent, or inside the function, it reflects over the y-axis. Remember, we actually learned that before, right? That's what we're going to be dealing with on the next page.